Hi, Mr. Richards here. Today's lesson is on solve equations with variables on each side. Now, our first example, example A, is 8a equals 5a plus 21. Notice here how we have a variable a on the left side of the equation and the a on the right side. Our goal when solving these is to get all of the a's onto one side of the equation. So we're either going to move the 8a from the left to the right, or we can move the 5a from the right to the left. And that's actually what we're going to do here. We're going to move this 5a over to the other side. Well, the opposite of this 5a is going to be to subtract 5a from both sides of the equation. Now what ends up happening here is 8a minus 5a, we use those coefficients, 8 minus 5 is 3a. Now that's going to equal, notice how our 5a minus 5a cancels out to 0, so that just kind of cancels, and we're left with the plus 21, or just 21. Now we have a one-step equation. We want to get the a alone. So if we divide by 3 on both sides of our equation, 3 divided by 3 is 1, and that cancels, and a is going to equal 7. Now we should check our solution as well, and we start off by rewriting the original equation. 8a equals 5a plus 21. What we're going to do is put the 7 in for both of these a's, so 8 times 7 should equal whatever 5 times that 7 plus 21 is. Well, 8 times 7 is 56. And that should equal 5 times 7 is 35 plus 21. Well, we have 56 simplified on the left side, and 35 plus 21 is 56. And since left side equals the right side, a equals 7 is our solution. Next, as we look at example B, 3x minus 7 equals 8x plus 23. You can notice where we have a 3x on the left side and an 8x on the right side, so our first goal is going to be to move either the 3x or the 8x. We want to move all the x's onto one side of the equation. Now mentally, think. If I were to subtract the 3x from both sides, this goes away, and then I have 8 minus 3 gets me a positive 5. If I were to subtract the 8 from both sides, this goes away, and I'm left with 3 minus 8, which gets me a negative 5. Now, both work. Let me be clear with that. Both work. But when I look at this mentally, I'd rather personally work with positive numbers. It doesn't mean you have to, but I'm going to choose to subtract 3x from both sides here. Again, you could choose either, and you should get to the right solution. Now, as I cross off the 3x minus 3x is 0, I'm left with, pay attention to this minus sign, negative 7 equals 8x minus 3x is 5x plus 23. Now we want to work to get the x alone. We have a two-step equation left. So I want to move this plus 23 by subtracting 23 from both sides of my equation. Negative 7 minus 23 is negative 30 equals 5x. And lastly, when we divide by that 5 on both sides of the equation, we're left with negative 6 equals x. Now we do need to check our solution as well. We'll start off by rewriting the original equation, 3x minus 7 equals 8x plus 23. Now if we substitute in that negative 6 into both spots, 3 times negative 6 minus 7 should equal whatever 8 times negative 6 plus 23 is. Well, 3 times negative 6 is negative 18 minus 7 should equal 8 times negative 6 is negative 48 plus 23. Well, negative 18 minus 7 is negative 25. Negative 48 plus 23 is also negative 25. Since the left side equals the right side in our check, negative 6 does equal x. In example C, we're going to get to write an equation to represent a real-world problem. The length of a flag is 3/10 of a foot less than twice its width. If the perimeter is 14 4/10 feet longer than the width, find the dimensions of the flag. All right, let's draw ourselves a nice little picture here of what this flag could look like. The width is W. Now my length is going to be 2 times the width minus 3/10. As it says, the length of the flag is 3/10 of a foot less than twice its width. So 2W minus 0.3 or 3/10. Now perimeter, it says, is equal to the width plus 14 4/10, as the perimeter is 14 4/10 feet longer than the width. Next, we get to ask ourselves, how do I traditionally find the perimeter of a rectangle? Well, perimeter is usually equal to 2 times the length plus 2 times the width. This is where I get to substitute some things in now. My perimeter P is going to actually be the W plus 14 4/10. I'm taking this P equals W plus 14 4/10 and putting it in for this P. That's going to equal 2 times the length. Now notice, I have my length here as 2W minus 3/10, as I simply substituted in the 2W minus 3/10 in for this L, then plus 2W. And so now I have an equation where I have the W as my single variable, even though it's on both sides of the equation. And now I get to simplify and solve. We'll have our W plus 14 4/10 here on the left side for a little bit. And that's going to equal, I need to distribute this 2 to the 2W and the minus 3/10. So that 2 times 2W is 4W, minus this 2 times 3/10 is 6/10. Then plus 2W. One of the key things before you decide to move variables or anything from the left to the right or the right to the left is to make sure everything is simplified on the sides. Now on the left side is simplified. The right side is not yet. I have a 4W and plus 2W. I can add those. So that W plus 14 4/10 is equal to 6W minus 6/10. As I simply added 4W plus 2W to get the 6W. Now we can subtract this W from both sides. This cancels. We're left with 14 4/10 equals 5W minus 6/10. Add the 6/10 next to both sides. 15 equals 5w. And our last step here, divide by 5 on both sides of the equation. And 3 is going to equal w. Now we're looking for the total dimensions, not just the width. Luckily, we know that the length is equal to the 2w minus 3/10. Now that I know my w is 3, I can substitute that 3 in for w. 2 times 3 is 6 minus the 3/10, and length is going to be 5 7/10. And both these units here are going to be feet. So if we start off by drawing ourselves a picture, we wrote our length in terms of the width, 2w minus 3/10. We wrote our perimeter in terms of the width. The perimeter is the width plus 14 4/10. We use our perimeter equation. Perimeter equals 2L plus 2W. We put the W in there for the P, W plus 14 4/10. We put the length in terms of W, 2W minus 3/10. And then we just use different properties such as the distributive property, combining like terms, and then adding and subtracting and dividing in order to solve the equation. Our next example is example E, and for some reason our book skipped D, so we're going to call this example E. 1/2 P plus 7 equals 3/4 P plus 9. Well, we know that we're going to have to get these P's on the same side, like 2 P's in a pod. And in order to do that, we're either going to be subtracting 1/2 P from both sides or 3/4 P from both sides. Well, the first thing I would do is to get common denominators for the half and the fourth. And that is going to be fourths. So the 1/2 is going to actually be 2/4 P plus 7 equals 3/4 P plus 9. Now, let's subtract the 2/4 P from both sides. Those cancel. We're left with 7 equals 3/4 minus 2/4 is 1/4 P plus 9. Next, subtract the 9 from both sides of the equation. And remember that 7 minus 9 is a little bit different than 9 minus 7 because 7 minus 9 is -2 equals 1/4 P. Now think back to the first lesson in this chapter. We can multiply by the reciprocal of 1/4, which is just 4, on both sides of our equation here. This cancels out. We're left with -8 equals P. Now we still need to check our equation. We'll rewrite the original equation 1/2 P plus 7 equals 3/4 P plus 9. Substitute in your -8. So 1/2 times your -8 plus 7 needs to equal 3/4 times -8. Now I'm going to write this as -8 over 1 to help us visualize what happens next. Plus 9. Now, 1/2 times -8 is simply -4 plus 7 equals, for the 3/4 times -8, why don't we cross-simplify? We can divide a 4 out of both the 4 and -8 to get 1 and -2. So that 3 times -2 is -6, and over 1 is just going to be -6, plus 9. And we end with 3 equals 3. And so -8 equals P is our solution. Now just one more example to leave you with, and that's example F. Negative 5/4 C minus 1/2 equals negative 3/4 plus 5/8 C. Well, here what I would do is to again get everything into common denominators. And for 4, 2, 4, and 8, that common denominator is going to be 8. And so our negative 5/4 becomes negative 10/8 C minus 4/8 equals negative 6/8 plus 5/8 C. Now we get to move our C's from one side or the other. We can either subtract 5/8 C from both sides, or we can move this negative 10/8 C. Well, let's look at the negative 10/8 C. The opposite of negative 10/8 C is adding 10/8 C to both sides. And hopefully you can see that this is negative 4/8 equals negative 6/8 plus 15/8 C. Next, let's add 6/8 to both sides. We are ending up with 2/8 equals 15/8 C. And since I'm running out of room, I'm going to move up here to finish the problem. I'll just rewrite this. 2/8 equals 15/8 C. Our last step here is to multiply by the reciprocal, which is going to be 8/15 on both sides. And a cool thing happens. This cancels. And then our 8's here can actually cross simplify as well into 1 and 1. And so all we're left with is 1 times 2 is 2. 15 times 1 is 15. And so 2/15 equals C. Of course, it's still important to check this. And so if we start with our original equation, negative 5/4 C minus 1/2 equals negative 3/4 plus 5/8 C. And now we'll substitute in our 2/15. So negative 5/4 multiplied by 2/15 minus 1/2 is going to equal negative 3/4 plus 5/8 times 2/15. Now let's look into cross simplifying here. The negative 5 and the 15 becomes negative 1 and 3 by dividing out a 5. Then our 4 and our 2 can become a 2 and a 1 by dividing out a 2. Over here, we can do the 8 and the 2 by dividing by 2 to get 4 and 1. And the 5 and the 15 we can divide by 5 once again to get 1 and 3. Now, where does that leave us? Negative 1 times 1 is negative 1/6 for 2 times 3 minus 1/2 needs to equal negative 3/4 plus 1 times 1 is 1 over 4 times 3 is 12. Now, as I'm running out of room quickly here, let's see if I can slide this up. We'll have negative 1/6 minus 1/2. We get common denominators there. That's going to be a 6. So negative 1/6 minus 3/6 is going to equal negative 3. And actually, if we're getting this as a common denominator of 12, this is going to be negative 9/12 plus 1/12. Negative 1/6 minus 3/6 is negative 4/6. And that's going to equal negative 8/12. We slide up one more time, simplify both those fractions, and see if we get the same thing. Negative 4/6 simplifies to negative 2/3. Negative 8/12 divided by 4 on top and bottom also simplifies into negative 2/3. Good fraction practice here. 2/15 equals C is our solution. So whether you are using integers or fractions, we can still solve equations with variables on each side and check them too. And that's it for this lesson. Good luck.